I feel quite privileged to be able to come to England and to pay tribute to David and also to Elizabeth. They've been great friends over quite a few years now. They visited us in Canberra on one occasion, and we've visited them on many occasions when we've come to England. I particularly like this photograph. It should be a painting, I think. Okay, so David and I, most of our correspondence, which stretched over quite a few years, was about this collinear arrangement of planets, also known as the Proto-Saturnian story. So what I thought I'd do first is to just give you some impression of how I got involved in all of this. I was, of course, inspired by Velikovsky, not long after the first book was published, Worlds in Collision. So I went into university as a total skeptic, which I think is a great way to be at university. I managed to survive through till the postgraduate year and then gave up, realising there's no place for a heretic in academia. Anyway, many years later, I made first contact with the SIS in 1979. I was working for the Australian government at the Australian High Commission in London, and I organised to meet with Harold Tresman and Roy McKinnon. You can see in that photo, that was in a cafe in Tottenham Court Road. And we discussed my possible involvement in the SIS. At that stage, I didn't know that a little over, well, less than 2 years later, I would be posted to London for 3 years. At that first visit in 1979, I met up with Malcolm Lowry because I'd been corresponding with him about a possible article for the SIS Review, and he encouraged me, and my very first article published in the SIS Review was due to him. It was about the recent evidence for Venus having been a new planet. Now, to do with Saturn in particular, 1977 marked the beginning of publications about Saturn, but I don't think I took a great deal of notice at the time. The 3 articles that came out were written by David Talbot, Dwight Cardona, and jointly by Harold Tresman and Bernard Newgrosh, who was under the pen name of Brendan O'Gagan, I seem to recall. It was Emmanuel Velikovsky in that short article in Kronos, Volume 5, Number 1, that really made me think about it, because that was such an incredible leap from anything I'd heard before. But somehow, intuitively, I sensed that there was something to be investigated there, and that it did, in some ways, make good sense. The essay itself was based upon a lecture given by Velikovsky at the University of the New World, Valais, Switzerland, in 1971, but it referred back to an article that he'd written called Saturn and the Flood back in the 1940s. So it has quite a history. In 1980, David Talbot published The Saturn Myth, which gave his reconstruction of what was seen in the ancient skies. I bought that book, and it was years later that somebody asked me if they could have a copy too. And that put me in touch with David Talbot once again, and from there the collaboration which has resulted in the Thunderbolts group in the US, that was born. My first real contacts, apart from the early meetings of the SIS in the early 80s, where I first met David and discovered that he was a man who was not to be put off by anything when he was inspired with an idea. When I came back in the late 80s on a second posting to London, which is highly unusual, I was involved both times with the committee. And there's a few photos here just as a reminder of some of the people who were involved at that time. David Roth, you can see. There's Bernard Newgrosh, Derek Shelley Pearce and Alan Newby in the small cameos on the left. And of course, Jill Avery features in the background. As Barry mentioned in an earlier address, David wasn't afraid of controversy. He defended Peter Warlow's elegant, and I think it was elegant, tip-top Earth inversion model against both the sceptics and the pseudo-sceptics, amongst whom I count Tim Thompson, who many of you know. And I thought that was an excellent piece of work. But David wrote to me about this question of external electromagnetic influences as being a driver for that tip-top or to trigger to cause the inversion of the Earth. And I think that's the most likely explanation. Because apart from the idea that the crust may be uncoupled from the core, because the core is supposed to be liquid, there is the issue that if the magnetic field of the Earth is largely due to the rotation of a charged body, and that rotation does not change in direction, then the magnetic field will not change, even if that body is inverted by that tip-top mechanism. So these are the sorts of things that David and I corresponded about. This is my first memory of the new house. I rather like it. I've actually printed a copy of this picture that I found on my archives and handed it to Elizabeth. They were good times. I've spoken on behalf of Eduardo earlier, and his address at the last Thunderbolts conference in the US was actually titled Strangers in a Foreign Galaxy. But I thought I'd just tone that down a little, because that's even more extreme than the idea that Proto-Saturn was just captured from the stars of our own galaxy. But he had arguments as to why he thought this might be the case for Proto-Saturn. I must say the Thunderbolts conferences are a real event to put on your calendar if you can possibly get to them. The next one is in March in Albuquerque, New Mexico. We've been to that venue before and it works extremely well for us. And the people who speak to us after the conference say they've never been to a conference like it, because it doesn't matter what you're interested in, there's practically a speaker there who will address that issue. Not only that, all of the speakers converge in their ideas, and this is typical of the electric universe. Eduardo, of course, has published a number of books in a never-ending series, it seems, and Godstar is one of them, which is about this idea that Proto-Saturn, we call it Proto-Saturn because the planet we see today does not look anything like the object that it was before in its past history. I spent decades trying to figure out how you would get a linear arrangement of planets that could be dynamically stable. When I first went to Portland in 1994 to address the meeting that David Talbot had organised, the first international conference on the Saturn story, I had really at that stage no idea how this configuration that he was describing would work, except that I could see that the details that he'd deduced from the evidence showed that it was electrical discharges in a plasma that was involved. It took a long while to get over the idea that Einstein knew what gravity was all about, and in ditching that, to find a modified version of gravity. I mean, Newton had the sense not to propose a theory. He just described what gravity does in mathematical terms. The result of that has been, in the last few years, what I call electrically modified Newtonian dynamics. And that hinges on the fact that when you put charge on a planet or a star, or extract charge to any great degree, the actual apparent mass and gravity of that star or planet will change. And it works in a very simple way, so that it's possible, using this EMOND, electrically modified Newtonian dynamics, to explain how you end up with a stable system of many bodies orbiting the Sun after a very short period of time when chaos reigned. And this was something that had never been done before. And it's such a simple theory that I think it has considerable value. So this electrically modified Newtonian dynamics then helped explain the electrical capture of proto-Saturn into the Sun system, the avoidance of planets of each other, and rapid orbit stabilisation. It also explains the transition of the captured system from a brown dwarf system of planets to a gas giant and scattered objects within the solar system. It's interesting to note that the most recent National Geographic has the usual story, and that is our wild, wild solar system. And you see a Mars-sized object colliding with the Earth to provide us with a moon. This story is so incredible and impossible that it just fits together with the other theories about how the solar system were formed, all of which don't work. There's been various models of this polar configuration. One of them was put forward by Bob Grubauer at that 1994 meeting in Portland. And that was very clever, but I thought it was a very special kind of arrangement which had Jupiter as the sort of counterweight to this line of planets. It fulfilled the requirements of David Talbot's reconstruction and also Eduardo's, that Earth was one of Saturn's satellites initially. This thing was called the barbell model, but it required that the whole system rotated once. This line rotated once in each year, so it went around like this around the Sun, which is a very special condition. I didn't like it, but Dave Talbot at that stage had been interested enough to see any explanation that it resurrected his interest in continuing, because he'd been rather discouraged by the sheer apparent impossibility of what he had reconstructed in the Saturn myth. The usual old story, I don't have to go through that. You see it endlessly on television and so on, with gravitational collapse, and somehow or another it forms a disk of gas and dust. Somehow or another that forms planets, although Saturn's ring doesn't form anything at present. And also every new discovery of exoplanets has the theory discredited, discredited. To begin with, they began to find super Jupiters, hot Jupiters, orbiting very close to the star. Well, according to this theory, they cannot exist except at some distance away from the star where those light gases aren't dispersed. So then they came up with migration of the planets, and it's got to the point now where we must have had another gas giant in our own solar system to be able to explain Neptune, because Neptune can't have formed where it is now, so it must have been knocked out there by a gas giant that no longer exists. It's getting just that crazy. On the right-hand side, you'll see a miniature solar system. This is the kind of thing that's being discovered. Red dwarfs have their own little planetary systems. But there's more to it than that, because the electric universe says we don't even understand our own star, and that stars are an electrical phenomenon themselves. And therefore, what is a red dwarf? Well, let's look at giant red stars, which we can see quite easily. Betelgeuse is a good example. Betelgeuse is so distended that if it was in this solar system, Jupiter would be orbiting just beneath the surface of that star. When I say that, these stars vary in radius for unknown reasons, and also have spots, hot spots, which are also unexplained. The electric universe says all red stars are giants, so there's no such thing as a red dwarf. A faint red star is still gigantic compared to a bright star. And the reason for that is that a red star has its plasma envelope expands to try and collect more electrons from the surrounding plasma, to satisfy the discharge of that body at the centre. And so this red sphere of plasma is glowing at the outer periphery largely, because that's where the electrons are accelerated. And inside you've got a very thin gas. It's been said that the planets could quite easily orbit inside Betelgeuse's atmosphere because it's so thin. So you can have a planetary system inside a star. And this is an idea that fits the work of Dwight Cardona in particular, about the earliest recollections of mankind about the light in the sky, the even temperatures and so on. So these all red stars have a bloated glowing plasma shell. If Jupiter's plasma sphere was visible, if it was glowing, it would appear as big as the full moon in the sky at night, yet it's a huge distance further away than the moon, just to give you an idea. So satellites may orbit within that plasma sphere, and in this case it's my contention that red dwarfs are the most likely place to find life in the universe, because here you have even heating of all the bodies orbiting within this plasma shell. It's like an incubator. The central star has a tendency to flare and throw off material into that atmosphere just to adjust to the electrical environment. And the early recollections are of a mist falling to the Earth continually. So the origin of the water on the Earth can be explained in this case, and also the icy satellites of the other gas giants. Where did all this water come from? And particularly on the Earth, I mean, we've got a huge amount of water, and in our position in the solar system, the standard theory says the sun should have blown that away. So there's an ad hoc theory that comets must have hit the Earth and produced the water, but now they find that the deuterium signature is wrong. So on and on it goes. This is a much simpler story. So, as I said, even red dwarf stars are gigantic. And the Earth, if it was orbiting, as I've shown here, inside that glowing plasma shell, every square metre on the surface of the Earth would receive the same amount of radiation, radiant energy. What's more, the colour of the light would tend to be purple, because you get UV and the violet end of the spectrum and the red end of the spectrum from this plasma. And that's the recollection of mankind, the purple dawn of creation. And the light was dim. Nowadays we know that red light is very conducive to photosynthesis. And what did we have? Huge forests covering the Earth in the polar regions as well. So all of the conditions are fulfilled here to explain all of these apparent anomalies. So this is a slide which sort of summarises the sun's environment to give us an idea of what proto-Saturn must have encountered as it approached our sun. It's not simple. In the early days when David and I were corresponding, trying to figure it out, we both came to roughly the same kind of figures, about a century or less for proto-Saturn to approach the sun, enter the heliosphere, and then break up. But when you look at this on the left-hand side, you can see what's called a planetary nebula. Now, these planetary nebulae are special cases where the circuit that drives the star is a light, and you can actually trace it. You can see it. And I've blown up the tiny bit at the centre, which is where the star is, and when you blow that up and then you go inside that, you find the heliosphere, and you see that the sun's heliosphere is actually a tiny part of a much bigger circuit. So proto-Saturn approaching the sun could have taken a very long time indeed, much more than centuries. And the effects on it would have been variable depending on where in this circuit it happened to be at the time. And one of the things that, as I said, a red dwarf star does to accommodate to its environment is to flare. And that's one of Dwight's tomes is called Flare Star, because that's the memory of mankind as well. This is taken on one of our many visits to the new house. Very many fond memories. And I have a saying, I think, that came from the Reader's Digest, that David was one of my most unforgettable characters. You know how you have certain people in your life that have an influence way beyond the ordinary? And David was one of those people. And with Elizabeth, wonderful hosts. And David was an indefatigable correspondent. I have many of his letters at home. I'm afraid I was rather lazy. I would wait till I came over and saw him face to face before I answered his questions. I've also got David to thank through Lee here for being invited to the Bath Royal Literary and Scientific Institute just in 2010, I think it was, to address the audience there. My view has always been that the electric universe will only take root by networking, and that is the more people we can address in as many venues as possible and via the internet, that's the chance for the future. That's the way things will happen. In fact, I think it's almost amazing how technology and this new paradigm have sort of grown together, because we definitely require the connectedness of the internet to demonstrate the connectedness of the electric universe. Anyway, that's it. Thank you very much. Thank you. We have time for a quick question, I think.
Last time I met you and now, you advocated the interaction between people to spread this message, to go forward.
Yes.
What I'd like to ask you is, you obviously have got an audience in things like the SIS and the New Mexico place that you talked about. Have you any interaction actually with the younger generation, say 11, 10-year-olds, 9-year-olds?
Yes.
Where you can interact at these events or such a time the same, so they can see how the grown-ups are thinking?
Yes. Well, just two examples. We had a teacher friend in Japan who was teaching at a school there to Japanese children who were learning English, and she knew of my work, and so I would speak to them on Skype. They would write their questions out and come up to the camera and ask their question politely, and then they projected me from Australia on a big screen, and I gave them an answer which I hoped was at their level and to hope to inspire them. So that was one of my little efforts. The other thing is that the Thunderbolts group are well aware of this problem of trying to involve younger people, and so for the last 2 years we have instituted a scholarship program. And one of those, they've been quite successful, by the way. One of the scholarship winners never went to university, but he's obviously a very bright fellow. He is now a laboratory manager. Another one has joined Jerry Pollack, Professor Jerry Pollack at the University of Washington, and working on this, the electrical nature of water in biology, which is fantastic work. Jerry Pollack is a big supporter of us, and we of him. So at the last meeting, I think we had about a dozen people, young people, and they seemed to have a great time. They were talking, they collared me many times in the corridor, and I'd get sore legs standing there talking to them. So there's definitely an interest out there, and we're doing everything we can to encourage it.
May I suggest you write a children's book on sort of like beginnings with electrons, protons, and go up through to where the electric universe is?
Very good suggestion.
If they're interested in it?
Yeah, I have my plan is to write the complete electric universe, because I've never actually gone into all the corners that the EU has an impact.
May I encourage that?
Thank you. Thank you.
I have a little problem with the end of your presentation.
Yes.
When you said the title of Cardona's book was Flare Star, and at the time the Earth would have been within the outer glow surface of the red star.
Yes.
Now, if something flared, it would be out on the outer glow surface.
Not necessarily. No, the central object is the main charged object, the anode in the discharge, if you like. And if the disturbance is sufficient, the anode itself will disgorge material. And this appears to happen. Red stars have surprised astronomers by A, producing jets, and also strong X-ray outbursts and flares. None of these things are supposed to happen in a star that never quite made it.
The other point was, under that scenario, you can't have any ice on the surface. You can't have ice on the surface of the Earth.
No, if the...
Cardona seems to think you could.
He's got an interesting model, which I think is very inventive. As to whether it's correct or not, that's up for discussion. This is the fun of the discovery, of course, is people throwing objections, and then you've got to go away and think about it. You don't just dismiss these things out of hand. So he's made some good arguments. Yeah. And I think that happened actually after the split, the breakup, though.
So the surface of the ice is thousands of years, whatever it is, that the sun was already influencing and caused the heavy light of the glow of the inner part of the star is already.
Yes, yeah, yeah. That's a bit of a complicated question. I'd have to research it to give you a good answer.
No, it's just trying to get your gauge of how long ago
Oh, I see.
might be ice on the surface of the Earth.
Yeah, this is one of the questions he gets asked all the time, and all he can say is it's roughly coincides with the end of the last ice age, which of course is a bit of a circular argument. It's very hard to tell, of course, because our normal means of dating rocks and things is in question with all of this.
You would say that the ice has to face-stage the collapse of the outer sphere.
I'm not sure. I'd have to talk to you about that. Yeah.
Wasn't Proto-Saturn supposed to have been a cathodic star?
The definite.
Approached the anode, its sun.
Yeah, the character of a body, whether it's an anode or a cathode, is entirely dependent on its environment. And in the case of the heliosphere, because the sun is a much more positively charged dynamic body than Proto-Saturn was, based on its brightness, then Proto-Saturn outside the heliosphere was a star, but as soon as it entered the heliosphere, it was suddenly negatively charged with respect to the sun. So it's always with respect to something. In that case, it switched from being a star to a comet, because the standard activity of a body that's approaching the sun that's negatively charged is to discharge as a comet. And I think that's what the origin of the polar column was, because we were sitting by then in the tail of this discharge. That's the most likely thing, I think. Yeah.
Degrees of negativity.
Yeah. When you say something is positive or negative, it has to be with respect to something. You know.
You mentioned at the beginning of your lecture about the Earth being within, if you like, the sphere of this red star, and you also mentioned that there were lots of forests scattered all over the Earth.
Yes.
Now, the thing is, the atmosphere of the Earth, would it have had the carbon dioxide required for photosynthesis and the evolution of oxygen, and would not the atmosphere of the, if you like, the environment in which the Earth was placed have engulfed any atmosphere that might have existed?
The atmosphere of the Earth, we know, was different back then. There was much more oxygen, apparently, and presumably the carbon dioxide must have been there for whatever reason. Part of it due to the carbon compounds that we find on those bodies that are out there orbiting Saturn right now. Titan is a good example. And also Venus was born from Proto-Saturn. It too has an incredibly thick atmosphere, just like Titan, only of a different composition. And I've explained why there's a difference in one of my articles on my website. So it makes a coherent story, and it's also been predictive. I was the only one who predicted that what they would find beneath the clouds on Titan. I was the only one who predicted that the poles of Saturn would be found to be hot, although it had just come out of 14 years in darkness. All of these things are easy to predict from the new model, and the success rate has been what you would expect if we're on the right track. I think we have limited time, so I think we'll call it a halt there. And Pepe, did you have something you wanted to say?
I just want to say a huge thank you on behalf of my mother, of my brother, Kit, who lives with us in Hong Kong, very sadly can't be here today, and myself, and I know David too. I found this immensely moving. It's reminded me again how incredibly privileged I was to be his daughter. Much I took it, well, I don't think I took it for granted, but it just is that reminder of what person he was. One of the themes today has been the way that David pushed back barriers. He wouldn't acknowledge barriers. He saw them as a minor inconvenience to be overcome. And one of the stories that's entered our family legend is of David taking me, and I think my brother, who was in a carry cart, down crumbling cliff steps, past the notice which clearly said hazardous, do not enter, to get down to the beach, because it was a beautiful beach. And that has entered my psyche. My brother and I believe there are no barriers. And Chris was saying at lunch, where did this come from? Well, David endured many childhood illnesses as a child. Indeed, he joked at the end of this 2-year period, he looked like a Alicia Beacon. He was just a skinny little body with a huge head. Was off school for nearly 18 months. But during that time, his mother, who was also a remarkable person, one of the first female graduates, she read maths at Manchester University in the early 1920s, tutored him so he would not fall behind. So his early experience was that adversity was enabling. There were no barriers. And that belief in education is something that he certainly passed on to his children. I am a teacher and an educator. And the spirit of debate and inquiry and challenge and a good old family ding-dong around the table is still sustained in my own family, where often the washing up doesn't get done until after midnight because we've been sitting at the table arguing about everything in a very encouraging way. Now, inevitably, that meant that when my father talked to me about ideas from the SIS, I would challenge him. He's very sceptical. I found the talks that I've heard today completely fascinating. And I remember that the last long conversation I had with my father, leaving me with this strong sense that we've both taken something away from it. Somebody said earlier today, a discussion, a ding-dong with David was never negative. There was no animosity. You always felt that you'd learned. And I want to say that I think more than ever now, we need societies like the SIS. We're in a culture that pays lip service to diversity, but derides non-conformity. And it's that non-conformity that is at the root, I believe, of real scientific and human advance. We need this so much. So it is so good to see new members, to meet Marion today, to see some new members here. We need you. In the words of Margaret Meek, anthropologist, you may be small, but she said, never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it is the only thing that ever has. To use a metaphor that I hope my father would approve of, societies like yours are a kind of shamir, and I do hope that you stay strong, that you stay in touch with my mother and I, my brother, and power to your elbows. Thank you.